Dear students, I hope you followed the prism problems from the last class, the sections of solids problems. Today we are going to get started with the pyramid problems. The problem in front of us is problem 8 as I have listed here. I hope you have done all the 3 problems which were given in the class last class. I sent out the picture and then I gave 3 questions, so I hope you have solved them. So that will make it 4 plus 3. 4 I taught in the class and 3 of them are given to you as a assignment. So 4 plus 3 is 7 problems, and then this is the 8th problem which I'm going to solve for you. We'll just do 4 problems here and then I'll give 3 more problems for you as assignments. So you guys need to work on this. I hope you understood the sections of prisms. So we'll just get started with the pyramids today. Okay, read the first 8th question here. A pentagonal pyramid of side of base 25 mm and axis 60 mm long has its axis perpendicular to HP. Its base is parallel to and 20 mm above HP. One of its base edges perpendicular to VP and its axis 35 mm in front of VP. A section plane perpendicular to VP and inclined at 60 degree to HP is bisecting the axis. Draw its front view, sectional top view, and true shape of the section. So this is a pyramid problem. So as you know, unlike the prisms, like you have slant edges here, in prisms we do have uniform edges which are like straight lines, which is seen as a dot in top view. Here we do have the slant edges, so I will just see how it will go. So first step, as we always do, we'll get started with the base shape. So as per the question, where is the base shape? So it says axis is perpendicular to HP. So obviously I'll see my base shape in the HP, that is below the XY line. So let me get started with my XY line first step. Okay, even before that I would say I will just start off with the pentagonal pyramid, the shape of the pentagon. So let me just get started with that. So whatever the size is, this is the side. I'll just get started. I'll just draw the shape here. This is my pentagon. It has a center somewhere here, so I'll just draw the slant edges. These are the slant edges. This is something different from what we have in the prisms. Alright, so here we have the side is given as 25, so this side is 25, so you guys can mark this as 25 mm. This is your center of the prism. I'll just name this as A, B, C, D and E. This is the top view. Right, now he says the axis is 60 mm long, has its axis. The axis is how much in front of VP? Its axis is 35 in front of VP. So from here I'll count 35, like I'll have to measure it from here, 35. So I'm just taking it roughly. Alright, it's 35. Let's say this is 35. Then I'll just draw my XY line. Alright, so this is from the center, remember this. So this is from the center. I've drawn the XY line. Right, the base is done now. Now I need to go for the axis. Okay, let me just, my axis is 60 mm long. So let me just draw the axis here. So I'll just use a different color here. So I'll take my axis height, whatever given. Right, so it's like 60. Now this I name it as O dash. This is O and this is O dash, the corresponding. Now from here till here I'll draw the projection lines from A and E. A and E is coinciding. I'll just straight away get the projection line here, and for C I'll get it over here, and these are my B and D's projection lines. Right, like any other solid problem, first thing I'll just draw in the outlines. Let me get the outlines first. My outline, I'm just drawing the outline, and this is my base shape. Don't forget to do this. Many people do forget to draw the base shape, base projection. So now what about this one? Like this is my A dash, as seen directly. This is my I over here, and this is my A, and then O dash, A dash is seen definitely, and then C dash is seen definitely. So B is right here, so this I would name it as B dash. So A dash, B dash, C dash are seen directly. So I have a solid line, solid line, solid line. Right. Now what about D dash? D and E are coinciding with A and B and A respectively. So I would say this is D dash, this is E dash. I'm putting these in braces just so that I would know that it's a hidden line. Alright, this is my first step. I've drawn the base shape. I projected the height, whatever the height of this one is. I'll just have you do the dimensioning later. So this is the basic projection, front view and top view of the thing, like solid problems. But now I have to go ahead and do the sections of this thing. One of the base edge is perpendicular to VP. This axis, a section plane perpendicular to VP and inclined at 60 degree to HP. Perpendicular to VP and inclined to 60 degree to HP is bisecting the axis. So bisecting is, I will just take the midpoint somewhere here. Then my section plane is making 60 degrees. Okay. Now I'm assuming this is my 60 degrees. And then I'll just draw the section plane. So as I know, section plane at the ends, it will be thicker, alright. This is my section thick at the ends. Now let us see in how many parts is this cutting. How many parts is this cutting the solid? Alright. So here, starting off from here, I will just count from the solid lines. Solid line is my 1. I'll just use a different color. 1. And then this second solid line is this one. This is the third solid line. So I have line. This is only one OC line, so 1 point. Here I have OB line and OD line is also there. So this is the fourth point on the other side. And then I do have a AE, OE point right here. So that is my fifth point. So these are my 1, 2, 3, 4 and 5 points. Totally on the lateral surface I have so many parts, so many edges being cut. These are called the slant edges. Right. So slant edges are cut here. So I have 5 points over here. Alright. This is my front view. Like I numbered the points. Now next step, let me just project these points onto here directly. Like I'll just project the points here. This is 1 point, 1 point, and then 3 also directly I can project. Okay, this is my third point, and then 2 and 4 also I can just directly bring them down right here, the 2 points here and here. Alright, I'll just give some numbers here. Like I said, 1, 2, 3, 4 and 5. So this is the cut part. This was the cut part. Now I'm projecting the points down. Alright, you might have seen in my earlier class when I've done the cone projection, I've shown you how it is being cut and what do we see. Like, do we see a circle or do we see an ellipse, or depending on how it is cut and where it is cut, we'll see the shape. So this is the shape which I see. Pretty much it's a pentagon. So to the XY line, I'm setting a 45 degree on my drafter, and then I draw uniformly spaced lines. These are called hatching lines. I would use the 2H pencil for this. So 1, 2, 3, 4, 5. This is why. This is my sectional top view, as I told you. Sectional top view. So I see the section along with the remaining part of the base shape. So this part was gone. This part is removed. So the remaining part of the solid, this is called the truncated pyramid. If I want to say, it's a truncated pyramid. Okay, if it was cut parallel to this thing like this, then it would be called frustum of a pyramid. Now that it's having an angle here, some angle, this is like a 60 degree angle, alright. Right, so that's given in the question. Now the next step is, he's asking now my front view is covered. This is my front view. This is my sectional top. This is my sectional top. And then true shape of the section. This is the next thing I need to find out. Alright. So if I want to get the true shape of the section, what do? I'll have to draw one line. That's an auxiliary plane drawn parallel to the section plane. Okay, this is my section plane. So parallel to this, I'll set my drafter here, move it over here. Right. And then I'll get a line parallel to this. So this is like from this boundary to this boundary is all I need. Alright. I'll just draw till there. That should be enough. So this is my x1, y1. This is called an auxiliary plane. Now from here I'm just setting my drafter perpendicular to this line, and I'll draw the projection lines from 1 5. This is my 2 4. All right, this is my 2 4, and this is my 3 for my 3. Okay, I'm getting the points here. So you need to plan this place properly. So now to get my first point from x to 5, whatever the distance is, that I'll mark it over here. From x to 1, whatever the distance is, I'll mark it here. This is my 1, this is my 5. From xy to 4, okay, this is my xy to 5, xy to 1, xy to 4, somewhere here, xy to 2, somewhere here, and xy to 3, somewhere here. These are my 3 points. Alright, so I'll name this as 1, 5, 4, 3, and 2. So this I'll just join it. I'm just not using a ruler here. I'll just draw it quickly so that we can save some time here. So this is my, so to the x1 y1 I'll set a 45-degree angle and then draw the hatching lines. These are called the hatching lines. So now this is the true shape, by the way. Okay, true shape of the pyramid. This is the true shape. This is the sectional top view. This is the front view. This is the section line. Okay, so the section is perpendicular to VP. This is basically, this line is also called the trace. Okay, this is also called the trace of the sectional plane, which is perpendicular to VP. Alright, so please note down this question. I hope you understood this solution. Okay, if you have any questions, you might reach out to me either on WhatsApp, or you can mail me, or whatever. Alright, so please note this down. We'll just move on to the next question. So this is a square pyramid. The next question is, so this is a little different. Okay, it's a little different than what we are going to do earlier. So in this question, let me just go back to the previous question. 1 second, there's small discussion here. So now here, out of these things like OA, along OA, OB, OC, OD, and OE, these are the slant edges of the pyramid. One of the slant edges is parallel to VP, so that is this OC. Okay, so the OC is parallel to VP, that means parallel to XY line right here, and none of the other lines are parallel to VP. So that means the OC is parallel to VP, so the O dash C dash would be the true length. O dash C dash would be the true length. Remember this point. O dash C dash would be the true length. But O dash B dash, or O dash D dash, or O dash A dash, or O dash E dash, none of them are true lengths. So only O dash C dash is the true length. That is the true slant edge. True slant length of this pyramid is gotten here. You get it here. If one of these none of these lines are parallel to the XY line, you'll have to make it parallel like we have done in straight line. So I'll make this line parallel, turn it like this. This is center, this is radius. I'll just rotate, get this point. Then finally project this point over here, get the actual true length. Okay, true slant length. This is the true slant length. So this will be coming handy for you guys when we do the developments of surfaces. Alright, so just note that point. Okay, we'll just move on. So this is the next question, the 9th question. Okay, so here it's a square pyramid of side of base 30 mm and axis 55 mm long. It is resting with its base on HP. One of its base edges is making an angle 20 degree to VP, and the axis is 30 mm in front of VP. Draw its projections when it is cut by a section plane perpendicular to VP. Remember this, perpendicular to VP, inclined at 45 degree to HP, and passing through a point 25 mm from the apex. Okay, draw its true shape and the sectional top. Okay, please note down this question here and then just go through this sides the diagram which I've drawn here. So I started off with my base shape. This is my base shape. Right, the base shape is like one of the side is making an angle 20 degree to the VP. And then axis is 30 mm in front of VP. So from here till here, this is 30 mm. Okay, just if I have to draw this dimensions here, I'll just draw this as my 30 mm. Then what is this side here? Side is given as how much? Whatever the side is. Okay, it's like 30 mm also. 30 mm side, right? What's my axis here? Axis is 55 mm. I'll just draw the projection line here and then put it over here. Okay, make sure you guys do the dimensioning properly. So this is 55. Okay, so this is the basic things which you have to draw. First, always start off with the base shape. The base shape is a square of 30 mm. Right, and then it has slant edges, OA, OB, OC, OD. These are the slant edges. Don't forget these things. You have to draw them. Right, and then this is the projection of the center line. This is your axis, whatever height that is. Right, and then like I told you, like the outline, this is an HB. I mean, I don't have any doubt in this one. So this is my HB. This part is there. This is my HB also. But now, seeing from here, I can see OA. I can see OB also. Okay, I can see OC also, but OD is behind my side. This is my eye here. OD is behind my side. So OD I can't see. So OB I can see. So I can put my OB as a solid line. Okay, this is my B dash. However, D is behind my side. So I'm just drawing a dashed line for the D dash line. O dash D dash. It's behind my side. So this is a dotted line. Okay. These both are different. This is a center line. This is a dotted line. Let me just put a color code here, just so that you guys have some clarity. This is the, so far this is the solution. The next thing is draw the projections when it is cut by a section plane perpendicular to VP and inclined at 45 degree to HP and passing through a point 25 mm from the apex. So 25 mm from apex is what I'll count here, and then it is perpendicular to VP. This is what perpendicular to VP is, right? And inclined at 45 degree to HP. So I'll just locate the 15 mm from the apex or 25 mm from the apex, and then set a 45 degree angle, and then start cutting this like this. So this is pretty much similar to what you've done earlier. But we'll see how, if there is any different. Okay, this is your section plane. This is making 45 degree to the HP. So this is what it is. Now let us get the points. Like I told you, like I'm starting off from the left side, counting off how many edges or slant edges is cutting. Okay, it has basically 4 slant edges, OA, OB, OC and OD, 4 slant edges, and it is cutting all the 4 edges, 4 slant edges. So obviously I'll have 4 points, but I'm starting off counting with the solid points, solid lines. Okay, number 1 is my first solid line, number 2 on OB, second solid line. So this is the third solid line, not this one. Okay, this is the third solid line on OC, and fourth is on the dotted line OD. These are the 4 points. Okay, if I want to put a dash, I can put a dash. Now let me get the top of the same. One is basically lying on which line? If I drop this down like this, one is lying here. This is my first line. This is my number 1. So 2 is lying on OB. So just let me drop this down onto 2, and then 3 is lying on OC. Let me get it on here. And 4 is lying on right here. Okay, so just let me just join these 4 joints, and whatever shape I have, this is the shape I'm just drawing the hatched lines over here. So this is the section what I get. This part was removed. So how the shape looks like is this one. This is the shape. This is called the sectional top view of the pyramid. This is the sectional top view. So I see the section along with the remaining part of the base. This part is gone though. So this one, if you want, you can just darken only this area below the section line. This could be darkened. Okay, this is a dark line. Alright, this part could be drawn lightly. Since you are already drawing with an H pencil, this will be light anyway. So this is darkened with an HB pencil. Alright, now he is asking, draw the true shape. Sectional top view is done. This is the sectional top view. So now I need to get the true shape. This is front view, anyhow you have to draw it. Alright, so now similar to what you've done earlier. So parallel to this one, I'm just drawing an XY line. X1, Y1 line. Between this boundary is enough for me. So this is my x1, y1. Now let me get these points. These are like, has to be drawn perpendicular to this x1, y1. So starting out from here, this is my second line, this is my third line, and this is my fourth line. Okay, so now measure the points, like from here, like whatever distance my one distance is, from xy to 1, whatever that distance is. Okay, that distance you mark it here, and then this is my 4 distance, right? So on this one, 4 is little here, and the third distance is 1C. This is my C line. Then this is my 2 distance. This is my 2. Okay, so now I can just blindly join these things. 1, 2, 3, 4. This is what I see, the same shape what I've got here, similar, but it's like elongated along this length. Okay, this width and this width is different. So this is a wider width. So this is what I guess. 1, 2, 3, and 4. This is my true shape. This is my true shape. Alright, so this is my front view, this is my sectional top view, and this is my true shape which I got. Okay, please note this down. This is your square pyramid. Side of base 30, axis to 55 long, resting with its base on HP. Okay. So let's go to the next question. So here, like if I have to ask a question for you guys, is there any true slant length seen in the front view? Is any of the OA, OB, OC and OD lines, is any of that line a true slant length? Can you say, anybody? Is any of the top view line OA, OB, OC, OD line parallel to VP or parallel to XY line? Okay, let me just put this XY. Okay, to the XY line, any of the OA, OB, OC, OD lines are parallel to XY line? Yes or no? It's a clear no, right? OA, OB, OC, OD, none of them are parallel. So how do I get the true length now? So using the straight lines concept, OC as radius, I just rotate it through and make it parallel to the